Can you solve this math challenge? Here's the question. Solve for the real value of x. Given this equation, 2 raised to x multiplied by 5 raised to x squared equals 10. You can pause this video if you want to give this problem a try. And now, let's answer this question together. So, our goal in this question is to solve for the real value of x. Given this equation, 2 raised to x multiplied by 5 raised to x squared equals 10. Now, here's some possible strategy to answer this question. The first one, we can use observation method. And the second one is the algebraic approach. This is, of course, the best way to solve this problem. We have the algebraic approach. But let's first use the observation method. Okay, now 2 raised to x times 5 raised to x squared equals 10. And take note that 10 can be written as 2 times 5. And 2 can be raised to 1, and 5 also can be raised to 1, and same thing as 2 times 5. Now take note, by observation, we can say that x must be equal to 1. But here's the question, is this the only real solution or real value for x? Now, we don't know if x equals 1 is the only real solution, so let's start our algebraic approach. So again, given this equation, 2 raised to x times 5 raised to x squared equals 10. Now, to answer this question using algebraic approach or using pure algebra, we will use the laws of logarithm a lot. Now, here's the first one. If we have b raised to logarithm of n to the base of b, this is just equivalent to n. We will use this identity to answer this question. Now, this 10 can be written as 5 raised to logarithm of 10 to the base of 5. Now, why we choose the base of 5? The reason is we want to make both sides of equation having the same base. If we have the same base on both sides of our equation, then we can now equate its exponent. Alright, so that's the plan. Now, how about these two? These two, using this identity, we can rewrite this as 5 raised to logarithm of 2 to the base of 5. Now, take note that we have the same base of 5. So now, let's simplify. Take note that if we have b raised to n raised to the power of m, it is equivalent to b raised to n times m. Therefore, 5 raised to logarithm of 2 to the base of 5 raised to the power of x can be written as 5 raised to x multiplied by logarithm of 2 to the base of 5. And also take note that if we have b raised to n multiplied by b raised to the power of m, it is equivalent to b raised to n plus m. Therefore, the left-hand side can be written as 5 raised to the power of x times logarithm of 2 to the base of 5 plus x squared. And now, we have two equal expressions having equal bases. Therefore, their exponent must be the same. So we can say that x multiplied by logarithm of 2 to the base of 5 plus x squared equals logarithm of 10 to the base of 5. Now, before we move on, let's rearrange some terms a little bit like this. So x squared is in the front. Next, this 10 is just 5 times 2. And now, we will use again some laws of logarithm. If we have logarithm of a times c to the base of b, this can be written as logarithm of a to the base of b plus logarithm of c to the base of b. Therefore, logarithm of 5 times 2 to the base of 5 can be written as logarithm of 5 to the base of 5 plus logarithm of 2 to the base of 5. And now, also take note that if we have logarithm of b to the base of b, it is equivalent to just 1. Therefore, logarithm of 5 to the base of 5 is just 1. Now, rearrange some terms a little bit like this. And then let's group those terms together. Now, why we do that? Take note that x squared minus 1, we can use difference of two squares here. So we can factor x squared minus 1 as follows. X plus 1 multiplied by x minus 1 using the difference of two squares. Also, This x times logarithm of 2 to the base of 5 minus logarithm of 2 to the base of 5. Take note that logarithm of 2 to the base of 5 is common, so we can factor out logarithm of 2 to the base of 5 like this. Finally, take note, we have also common term of x minus 1, so we can factor out x minus 1. This will give us x plus 1 plus logarithm of 2 to the base of 5 multiplied by x minus 1 equals 0. Now, since it is equal to 0, so we can equate both factors into 0. And now, on the second case, x minus 1 equal to 0, if we add 1 on both sides, we get the value of x as 1. We get this result using observation method a while ago. So x equals 1, definitely an answer to our equation. But here's the other real value for x. Now, on the first case, if we add negative 1 minus logarithm of 2 to the base of 5 on both sides, we get the value of x, the second value of x, as negative 1 minus logarithm of 2 to the base of 5. Therefore, we have two possible real value for x in this equation. We have x equals 1 or x equals negative 1 minus logarithm of 2 to the base of 5. And as always, we are done.